Thank you, Gaston, and everyone here. It's a pleasure to be here, especially on the last day. Have very many good memories of the time we've spent already and look forward to our excursions this afternoon and field trip the next few days. So today I want to talk about Roderick Murchison's work in the Donetsk coal fields. It was 180 years ago at this time of year that Roderick Murchison spent several weeks investigating the coal fields of the Donetsk region in what was then southern Russia. He had been commissioned by Tsar Nicholas and by the Tsar's finance minister, Count George von Konkrin, to investigate the extent and quality of the coal deposits in the Donetsk coal basin. He was also asked to suggest improvements in coal mining practices that could be applied in order to improve production of coal. The Russian government at the time was interested in expanding the railway system, as well as establishing steam-powered factories, and coal was a necessary source of energy to enable that transition. And at that time, the Donetsk coal basin was the most productive source of coal in Russia and was therefore of strategic importance. Why did the Tsar choose Murchison to undertake this task? Well, first, he was widely perceived as an authority on geological matters, including coal-bearing rocks. Second, he was a friend of Baron Brunnow, the Russian ambassador to Britain, who recommended Murchison to Konkrin. And it was partly for his report on the Donetsk coal fields that the Tsar awarded the St. Anne's Cross in diamonds to Murchison for services rendered. Murchison's growing reputation as an authority on geological matters is documented by his scientific pedigree. As this list shows, he joined the Geological Society of London in 1825 at the age of 32. He quickly rose in prominence and was first elected president in 1831. And it was during his second term as president from 1841 to 1843 that Murchison visited the Donetsk coal fields. Murchison had an important impact on the development of geology in the 19th century, and his reputation was well established by the early 1840s. His major scientific achievements ultimately included the naming of several Paleozoic systems, the compilation of numerous geologic maps and cross-sections, publications of more than 180 scientific papers, presidential addresses to both the Geological Society of London and the Royal Geographical Society, and 3 major books. It was this scientific output that formed the foundation of Murchison's reputation and brought him to the attention of the Russian government. Murchison's impressive scientific output was possible given his abundant energy, ambition, and networking skills. He was also a master at logistics and synthesis, and he developed a fieldwork methodology that enabled him to make rapid progress when mapping large areas. In this talk, an example of his fieldwork methodology as he applied it in Russia is presented. Murchison's fieldwork methodology, first of all, relied on detailed preparations. He typically assembled as much information as he could about a region he planned to visit. This included gathering together publications and maps and corresponding in advance with scientists who were familiar with the region. Once on the ground, Murchison invariably sought out local experts to ask their advice. He made a habit of visiting local museums to inspect the fossil collections, and where possible, acquired any geologic maps that covered those areas. Another practice Murchison engaged in was to travel with at least one other geologist. This permitted the exchange of ideas in the field and the verification of observations by another expert. Upon return from the field, he promptly announced his findings both at scientific meetings and in print. An excellent example of his fieldwork methodology in action was the work that he did that resulted in the mammoth book entitled The Geology of Russia in Europe and the Ural Mountains. The book is a handsome, well-illustrated, two-volume set published in 1845 by John Murray of London and P. Bertrand of Paris. Murchison wrote volume 1 on the geology of Russia, and his collaborator, Edouard de Verneuil, prepared volume 2 on the paleontology of the regions that they had visited. Volume 1 of the Geology of Russia is illustrated by a pair of maps, 5 plates with cross sections, a dozen lithographs, and 83 woodcuts. The map shown here is plate 6 of the Geology of Russia, and it is accompanied by a generalized stratigraphic section on the right margin and a cross section along the base of the map that extends from St. Petersburg on the north to the Sea of Azov on the south. The maps and sections of Volume 1 were the product of observations made during 2 extensive field campaigns in Russia. Shown here is the route that Murchison and his team took during the 1840 campaign, where they started in St. Petersburg and traveled north to Archangel before turning southward to Usting and Nizhny Novgorod. Their route then took them to Moscow on their way back to St. Petersburg. And during that expedition, they mapped crystalline basement rocks, unconformably overlain by the Silurian and Devonian systems. They also mapped the Carboniferous system, overlain by red sediments that would later be identified as the Permian system. The more southerly route taken in 1841 is shown on this map. That route began in St. Petersburg, then continued through Moscow, Kazan, and Perm before crisscrossing the Ural Mountains several times. The team then traveled back through Orenburg, Samara, Sarepta, and Novocherkassk before arriving in the Donetsk coal basin. Note the outline of the border between Ukraine and Belarus and Ukraine and Russia, and the boundary extends up into this area here. Note also that the Donetsk coal basin, which is this blue area here, is situated within eastern Ukraine, and it's the site of much fighting today. The southeastern corner of this map has Russian territory labeled, and this is the boundary between Russia and Ukraine, extending along that pathway there. So much of what's in the northwestern part of this map is within Ukraine. And as is the Donetsk coal basin. As we can see from the routes on this map, Murchison and his colleagues traveled extensively within the Donetsk coal basin, where they visited active coal mines in an effort to assess the quality and extent of the coal deposits. The sites they visited enabled them to map the extent of the Carboniferous, which is shown in blue. And upon arriving in the Donetsk region, they first traveled northward up the Kalmius River Valley along this route here, before turning east to inspect coal mines that occur in the eastern part of the Donetsk coal basin. From there, they headed westward as far as Petropavlovsk before returning to Bakhmut, where they then turned northward toward Moscow at the end of their field season. This extensive inspection led to the detailed geology for the Donetsk coal basin, which was incorporated into plate 6, as shown in the next slide. So this is a close-up view of the Donetsk coal basin from plate 6 of the Geology of Russia, and it shows locations of various coal mines as black dots. as well as cross sections, which appear as black lines on this map. So examples of black dots are right in here, and this is one of the cross-section lines here, another one here, another one over in this part of the map. The cross-sections illustrate the attitude and extent of the coal deposits. Murchison and his team spent several weeks on a close inspection of the Donetsk coal basin. They were not the first to examine the geology of the Donetsk coal basin. They were the first, however, to apply the recently developed Paleozoic system nomenclature to those deposits. Shown here is a geologic map of the Donetsk region made by Captain Ivanitsky, employed by the Russian government. The shoreline of the Sea of Azov is visible in the lower part of this map, and these blue areas up here are coal-bearing rocks in the coal basin. Murchison was provided with a copy of this map by General Chevkin, the Director of Mines and Public Works, when he was passing through St. Petersburg earlier in the summer of 1841. And this map today is in the archives of the British Geological Survey, and it has Murchison's handwritten annotations on it. Clearly, he had it with him at the time. These passages from the Geology of Russia identify the sources of information provided by the Russian authorities to Murchison, and it is clear that he benefited from access to that material when he was investigating the Donetsk coal basin. He points out that the previous workers had said, quote, that owing to the convolutions of the strata and the want of fixed mineral characters, no regular order could be established, end quote. He went on to say, quote, to geologists, therefore, who, like ourselves, were thrown into a new field in which the succession of the beds was perfectly unknown to us, nothing could be more satisfactory than to find in one of the first sections we made a key to the whole order of this country, and by which we established the most ancient strata occupy the southern zone of this Carboniferous region. Thus, led to the Kalmius River section by reference to the maps and sections of Captain Ivanitsky and others, Murchison and his team were able to establish that rocks of the Carboniferous system rested on old red sandstone, which in turn lay unconformably on crystalline rocks and were dipping and ascending stratigraphically in a northerly direction, as will be shown in subsequent slides. Plate 1 of the Geology of Russia documents the attitudes and stratigraphic positions of the coal seams at 9 locations throughout the Donetsk coal basin. Figure 1, I'll draw your attention to that, is the upper right cross-section, and that's the critical Kalmius River cross-section. Let's take a closer look at it. Here it's shown in full at the top of the slide, and location is indicated by the red ellipse on the map. And if we look more closely at the southern end of that Kalmius River cross-section, we can see that there is porphyry and granitic rocks on the right-hand end at the base of the section, overlain by sandstones shown in brown color and labeled as old red sandstone. And then that in turn is overlain by limestones in blue and sandstones and shales in gray, dipping in a northerly direction. And note there is a coal layer right here shown in black, interbedded with some of the grits. This slide, this image, can be compared to the one that had previously been prepared by Captain Ivanitsky. So there's a great deal of correspondence between the two. The town of Karakuba is situated about here in both cross sections, and we can see crystalline rocks and porphyries overlain by northward dipping strata that belong to the Donetsk coal basin. So being able to refer to Ivanitsky's section no doubt assisted Murchison in quickly recognizing the Paleozoic systems comprising the stratigraphy at the Kalmius River section. Heading to the north, this is the north end of the Kalmius River section. And in this part of the section, you can see that the Carboniferous rocks are folded. The red circle on the map indicates the location of the Alexandrovsk coal mines, which Murchison described as 7 feet thick coal seam that was thinly bedded, bituminous, and containing pyrite. The coal was being mined by the government in shallow shafts located not more than 100 feet above the Kalmius River. The depths of the shafts were limited by the influx of groundwater, and steam engines had not been introduced to remove that groundwater, so the groundwater was limiting the depth to which those shafts could extend. This image is figure 2 from plate 1, and it portrays the northward dipping Gorodovka section, which is near the stratigraphic top of the Donetsk coal basin. The Carboniferous strata here comprise flagstones, grits, shales, limestones, and coal seams. And the coals are bituminous. Note that the north end of the section has Cretaceous chalks unconformably overlying the Carboniferous strata. And presumably, the Carboniferous strata continue at depth to the north, and if they contain coal seams, those seams may remain within reach of vertical mine shafts for some distance. This line of section is oriented southwest-northeast and passes through Bakhmut. The section is noteworthy because it exhibits a synclinal structure with the Permian beds occupying the center of the fold at Bakhmut. The section also shows a Cretaceous chalk unconformably overlying the Carboniferous to the southwest of Bakhmut, and that chalk is situated right there. And this is the synclinal structure in Permian beds. This slide compares the Bakhmut section as prepared by Murchison to an earlier one prepared by Captain Ivanitsky. And I think you can see the similarity in structural deformation. And clearly Murchison would have benefited from the data gathered by Captain Ivanitsky, as they both show that same syncline. Murchison assigned the core of the syncline to the Permian, a system that he was in the process of defining in 1841. By comparison, Ivanitsky assigned those red sandstones and shales to the Triassic. Thus, Murchison was the first to apply the newly developed Paleozoic system nomenclature to these rocks. This slide is figure 4 from plate 1, and it's a section at Krasnoy Kut, which was on land owned and occupied by General Papkov, and Krasnoy Kut is situated round about here on the map. This section contains a couple of anthracite coals that were being mined in adits in the hillside and were in beds that were 3 feet thick. And according to Murchison, these were excellent seams of anthracite that were indistinguishable from iridescent British varieties. Murchison also noted that these coals were far enough to the east to be anthracite as compared to bituminous coals that occur to the west. And he thought this may be due to the heating from below by emplacement of igneous rocks that may have converted the superjacent ordinary coal into anthracite and have indurated the associated grits, sandstones, and schists. Murchison also noted that the coal mined at this locality was used in steam engines in a nearby factory established by General Papkov. This slide portrays another anthracite coal-bearing section at Popovka, and this is figure 5 of plate 1. Once again, these are anthracite seams about 3 feet thick, and, quote, they were chiefly worked by galleries in which the poor Cossack miners have followed it to short distances from its natural outcrop on the sides of the brooks, end quote. Murchison also noted that if steam engine water pumps were introduced, the seams could be followed to greater depths and below the groundwater table. Murchison also noted that mining at this site was encouraged by the governor of the district, Count Woronzow, and the governor wanted the population to move away from scarce wood as a source of fuel. The coal being mined at Popovka was transported by light carts to Novocherkassk and to the iron forges of Lugan. This slide contains a shaft section of the productive Lysychia Balka coal mines. And again, this section was prepared by Captain Ivanitsky, and it records multiple bituminous coal seams shown in black, interbedded with limestone, shales, sandstones, grits, and schist. Note that these bituminous coals occur in the western part of the Donetsk coal basin. Murchison used Ivanitsky's hand-drawn shaft section in the previous slide to produce the detailed section in the Geology of Russia. As with Ivanitsky's original section, Murchison's section comprises interbedded sandstone, shales, limestones, and coals, and there are 12 labeled coals, and the section appears to record multiple cycles of deposition. Murchison interpreted the coals to be of submarine origin. This slide reproduces a portion of the stratigraphic column on the right-hand margin of plate 6 of the Geology of Russia. It provides a summary of many of the observations and interpretations made by Murchison concerning the Carboniferous system in Russia. He divided the Carboniferous into a lower Carboniferous in dark blue and an upper Carboniferous in light blue. And the Carboniferous is also divided into a north region on the left and a south region on the right. And the south region was characterized by having coal. So the right-hand side of the column portrays the stratigraphy of the Carboniferous system in the Donetsk coal basin. The base of the Donetsk section occurs at Karakuba, which is right about this level here on the Kalmius River. And the top of the Donetsk section occurs at Gorodovka, which is up here near the boundary between the lower and upper Carboniferous. Note that the multiple coal seams interbedded with sandstones and limestones and schists are similar to the detailed stratigraphy of the shaft section of Lysychia Balka shown in the previous slide. So in conclusion, I hope that I've shown that Murchison's activities in the Donetsk coal basin are a good example of his collaborative fieldwork methodology in action. First, he researched in advance by reading available publications and consulting with knowledgeable geologists. Second, he assembled relevant maps and publications to assist in his campaign. In this case, he made extensive use of Captain Ivanitsky's geologic map and cross-section. Third, he interviewed local experts and visited their collections. Of most use was the Donetsk Basin fossil collection of a Monsieur Leplay that Murchison had examined in Paris earlier in the year. Fourth, he traveled with other scientists to verify his observations. In 1841, he was accompanied by Edouard de Verneuil and Alexander von Keyserling while investigating the Donetsk coal basin. And fifth, he announced his findings both at meetings and in print, most notably in chapter 6 of the Geology of Russia. In addition, I hope that this talk accurately depicts Murchison's contributions to understanding the geology of the Donetsk coal basin. Some of his major findings include the following. First, Murchison and his team provided careful documentation of the occurrence and extent of coals throughout the Donetsk coal basin, both on the geologic map and in the associated cross-sections. Second, they established that the coal fields in the Donetsk basin were in rocks of the Carboniferous system that dipped in a generally northward direction. Third, the base of the Carboniferous was recognized by the contact with the underlying Devonian system and older crystalline rocks. Fourth, the top of the Carboniferous system was overlain by the Permian system. Fifth, Murchison recognized that the depths of mines were limited by groundwater and that steam-driven pumps would greatly increase the production from many of the mines. Sixth, Murchison recognized a regional change from bituminous coals in the west to anthracite coals in the east and attributed that gradation to heat emanating from the emplacement of granitic rocks at depth. And seventh, Murchison recognized that the Carboniferous stratigraphy of the Donetsk coal basin was distinct from Carboniferous rocks in the vicinity of Moscow. And as a final note, the coal deposits of the Donetsk coal basin remain of strategic value. They have likely played an important role in Putin's invasion of Ukraine. On this map, the current state of military operations is portrayed. And note that the Donetsk coal basin was already occupied prior to February 24th, 2022, as was the Crimean Peninsula, indicating that the coal deposits are highly prized by Putin. Thank you for your attention.
We have time for 2 or 3 questions.
Thank you, John. I should read your book. I think maybe it would answer my question, but I'm curious if in his journals and his letters to Charlotte, whether talks about the social milieu at this time in this region. I know, having read a history of Ukraine, it's like every year the boundaries seem to change in this region over centuries, and I'm just curious if he made those kinds of observations.
I think he was quite curious about the area he was traveling through, and in his journal accounts, he talks about prisoners being marched off to Siberia and landowners benefiting from the serfs and Cossack miners being exploited. So he is making those observations, but at the same time, he seemed to be a bit of a fan of Nicholas I. So he wasn't interested in changing the system. He was sort of interested in experiencing it.
Another question?
Thank you very much, John. It's always good to learn more about Roderick Murchison and his amazing travels. I would like to know, did Murchison identify the fossils that allowed him to say, oh, red sandstone, Carboniferous, Permian, etc., or did Ivanitsky before him identify those? This section that you showed, it's clear the coal fields are very like those in Scotland, for instance, where we have coals in the lower Carboniferous and right the way through. So that's my question. Did Murchison actually identify fossils himself?
He would identify fossils he was familiar with. That might not have been a huge list, but he was also traveling with Edouard de Verneuil, who was an accomplished paleontologist. So he would rely on de Verneuil's identifications for identifying age and stratigraphic position of the various rocks.
Last question.
Very, very nice talk, John. That was great. Do you know whether the Czar implemented any of Murchison's recommendations, for example, the use of steam pumps to pump the water and so on? Did his work change the way that the coal was being mined in the basin?
I don't have any specific data to say that happened, but over time, those coal fields have been developed more fully, and I expect that his input would have nudged the Czar and his ministers in that direction.
Okay, thank you.